Hey everyone, my name is Arvin. Today we want to dive into MCP servers and multi-agent systems and actually show you a practical example of creating and running a multi-agent system as a customer service for our application, which is actually one of the main endpoints on Senti project. So let's go back to the basics for a while and talk about the origins of function calling and actually give you an idea of on how this thing started. So uh, we started to use LLM to replace human in software loops. For example, in Senti, after adding our reasoning module, the responses had some weird hallucination, like the agent, actually the girlfriend agent, started to uh, get confused about its herself gender and the user gender, and it kind of got it all the way wrong. It considered itself as a male user on the website and the user as a female user, and so yeah, that was really weird for us. I think Delaram totally remembers that. So we decided to use the LLM to detect the hallucination and route the code to the correct function that replaces this hallucination with the correct response. So after a while, AI engineers got the idea of a calling function with LLM. So what they did was they created a schema, as you can see right here, to give a function access to LLM, so they can give us a sentence that can be converted to a language that can be used by a Python interpreter or other compilers to actually call the function. In here, we have two simple functions. The first one is getWeather, which here, this is actually a mock example. It's not going to call any API. It's just going to return the weather in a specific location is 22 degrees. And the other one is just going to return some random news. So first, we define the schema of our functions, which is getWeather and getNews, which you can see here. I'm not going to further explain it. Then we give that schema to our LLM in here. So if it triggers the function, it can be compiled into a transcript that can call the function and return the result to the LLM. As you can see here, after we call the LLM, it returns these lines, which is actually the result of our function. Now, after a while, we got frameworks and libraries that had predefined tools in them, like GitHub tools, which give us some tools to see the changes on a specific repo, see the pull requests, see the issues, and other things. As you can see here, I have GitHub tools and an LLM here, and I'm going to ask it about Agno project, which is actually one of the best multi-agent framework that I discovered recently. So when we run this, what it's going to do is going to call the GitHub API, get back a result, and then process that result based on the user query and return a response. And here, as you can see, it got the project README, summarized it, and provided it to us. So as we proceed, AI engineers wanted to make a standard way of using functions for LLM. So they decided to create an environment for these functions so they can easily add functions to that environment, edit them, update them without having to edit our code or make changes in our production. So I have some images here, some examples, which is here. So as you can see, MCP is the environment for a bunch of different tools and functions. So instead of directly calling those APIs, it's going to call the MCP. It's like an API server, which has a lot of endpoints categorized based on use case. So the LLM can use them and get back the result and process user queries. So yeah, this way we can easily add new functions here without having to edit our code, add new tools to the LLM code or anything. It's kind of like keeping our microservices clean without any messy code or other things. So this is our first example. So as you saw earlier, there's predefined tools, for example, for GitHub. But the problem is these tools might change. They are locally defined. They are not on GitHub servers because what happens is these tools call the APIs on GitHub server. So GitHub server might decide to change their functions and APIs, for example, to make it more flexible or more faster. What happens is they might add new parameters to these tools. And with the same tools that we have on our side, if we don't update the code, the API is going to fail. So we don't want that. Instead, we will convert the function into an MCP, which holds the functions in there. And each time the LLM is going to use those functions, it will get the results from it. So the schema will be updated each time. So as you can see here, this is the standard a GitHub MCP. It will have an command for us to actually implement the client on our side, so the LLM can call it in the Go. So we don't have to update this code anymore. We just have to update it on GitHub server. It's gonna stay the same, even if we wait for like half a year or so. It's gonna stay the same. We don't have to change this. GitHub is gonna change it on their side, and we don't care about that anymore. So in here, it's actually the same thing. It's gonna go and search about Agno project on GitHub, with the difference that it's going to be MCP this time. So I'm gonna run it. Hopefully, it won't fail this time. So here, as you can see, it will go to GitHub API. It will call the functions on the MCP server. It will get the README from Agno project and then summarize it for us. Yeah. Okay. So let's move on to multi-agent systems. So after a while, AI engineers discovered that they can actually batch off agents together and make them work with each other instead of actually connecting them with code and other stuff. So what happens is we will have a team leader, which is an LLM itself, and bunch of sub agents, which they have, again, an LLM on their side. So we will have a message from the client. For example, in this scenario, this is the customer support system. It will get messages from the client. So for example, the client might say, okay, the server is down. The team leader is going to get this message. It will analyze it and then say, okay, uh, if the server is down, I'm gonna call the test runner agent. So the test runner agent can call the API to see if the server is healthy or not. So if it's not healthy, it will inform the client that our server is not healthy, and then it's going to connect Asana and GitHub to create tickets and issues on there for the developer to fix it later on. So if another client comes in and tell the operator of our customers service system that the server is down, it's not going to go to the test runner agent again. It's going to tell the client that our server has issues. We already have the ticket and issues on GitHub and Asana, and it's going to be fixed. So stay tuned. Okay, so now we are going to explain how to create this orchestra of agents together in one code. So we have a bunch of different frameworks to use and actually create a multi-agent system, but I decided to go with Agno because I know most of you are familiar with Google ADK or AutoGen or something worse like LangChain, because LangChain is like a nightmare to use. It was released, I think, like a year ago, and exactly at that time when I used it for the first time, I really hated it. So, and I still don't like it, and I'm not going to use it. But with the release of Google ADK, most of the things changed, and people actually started to like this framework and use them. I think from our company, Hanif is actually using it in one of his projects, but I saw his post about not being able to use the service state and memory on MongoDB because Google is completely focused on Vertex AI and other Google services, so it doesn't have that much of a flexibility. Instead, Agno actually provides us with more than 5 databases. It has SQLite, it has MongoDB uh, built in, so we don't need to code things ourselves. It's going to be ready in a go. So first of all, we want to create our responsibility in a multi-agent system. So in here, we divided it into 4 agents. There is a leader which talks to the users and coordinate the system so it knows which agent does what. So the GitHub agent is only gonna access GitHub. It's gonna create pull requests. It's gonna update the readmes, or it's gonna create issues based on the user problems. The Asana agent is gonna access Asana projects on our Asana server and create tickets on there for the developers. And the runner agent, which actually our custom MCP, which I'll show you in a minute, is our own service, which is provided to the user and converted to an MCP server. So the test runner with an LLM can test it in real time and return the results to our team leader. So let's go down to the multi-agent system that we have in here. Okay, here it is. We have an GitHub agent. It has access to our GitHub MCP. It has some instruction. In this case, I had to copy paste the instruction and role to be the same thing because it has some issues. So I just copied them together and it was fixed in there. So yeah, this is the basic code for it, which I'm gonna provide you the notebook after the presentation so you can see it yourself. And then the Asana agent at the same arch here. You can see the command, the arcs for the MCP server, the instruction and the roles and our LLM. And at the end, we will have a leader, which in this case is actually the same as our operator, which talks to the user with this instruction and with the members. So when it runs, it can process the user problem. So I'm just going to run the UI and show you the actual product because I think it's more appealing for you that way. So let's hope it will not have an error in here. Okay, it actually works. Okay. Oh, okay, I made a mistake. I should change this port. Okay, so we are going back to the classical way of calling our module in console. So I'm just going to run it in here. So it's going to ask me for an input, which in our case was, I think the server is down. Please check. So what it does is going to call the Asana agent and GitHub agent to check the issue pool and the task to see if we previously added some ticket about the server being down or not. And after that, it will ask if it's found any tickets on there. It tells us that we know that our server has issues. So please stand by till our developers fix it. So in this case, we don't have any tickets regarding the server being down on GitHub or Asana. So it's going to tell us that we don't have anything regarding that the server is down. So would you provide me your test so I can test the API to see if it has any issues or not? So what I'm going to ask it is I'm going to ask it to run a health check on the API. Uh, so if it goes well, it will call the uh, agent with the access to our server MCP to test the server and get the result. Okay, so it says it should be run any moment now. Okay, and it needs another one. Okay, Okay, so the server apparently is okay, and we don't have any issues. Okay, and yeah, that's it. Thank you everyone for listening.